The Cascade Mountain Range is a highly scenic cluster of mountains spanning hundreds of miles in length that includes a number of well-known active volcanoes. These include Mount St. Helens in Washington State, Lassen Peak in California, and Crater Lake in Oregon. Yet, often removed from such discussions despite their rightful place in the Cascade Mountain Range are the Canadian portion and its active volcanoes. Part of this lack of inclusion might be owed to how little we still know about many of Canada's active or potentially active volcanoes, with Mount Garibaldi and Garibaldi Lake being two of the region's better studied Cascade Range volcanoes. As a result, there are still a number of understudied, scenic, and mysterious volcanic complexes in the region, with one such example I want to highlight being Canada's Silverthrone Caldera. There are no roads to this absurdly remote volcano located partially within an ice field 55 kilometers north of the town of Kincombe. This complex, as its name implies, is largely encompassed by a single massive caldera, most likely the largest caldera to form in the entire Cascade Mountain Range during at least the last 5 million years. This caldera, which the overall volcano is named after, is 31.6 kilometers long and 20 kilometers wide. For reference, this is about the same size as the Lone Valley caldera outside the Cascade Range in California, which produced a massive high-end VEI-7 explosive eruption 764,800 years ago. Thus, for all intents and purposes based on the size of Silverthrone's caldera, the singular eruption which formed it caused more than 400 square kilometers of ground to collapse downwards, probably depositing a very thick and widespread tephra unit involving at least 200 cubic kilometers of material. Despite the fact this represents such a large eruption, we don't know how old the caldera is, what composition it erupted, how widespread its destructive extent was, or other important factors. All we do know is that this caldera formed sometime between 150,000 and 1 million years ago. With such a young date, it signals that this remote volcanic complex could theoretically one day produce another highly explosive eruption. And, despite its mysteriousness, there is reason to believe that the overall complex is still active. Material buried under a lava flow at the approximate location shown on screen was dated 12,200 years ago. While this is not in the Holocene, which began 11,700 years ago, this sample was not directly beneath the relevant basaltic andesite lava flow as it was a little bit below it, so the lava flow likely did erupt during the early Holocene. Adding to this, the Silverthrone complex has produced occasional volcanic earthquakes, further suggesting that it is still active. This is why if we were to use the U.S. Geological Survey classification scheme of rating volcanoes, that the Silverthrone Caldera will be designated as a moderate threat volcano. While few people live nearby, any future eruption could melt large volumes of ice to generate lahars that could affect those who live in Kincombe. The highest peak and namesake peak of the overall volcano, Silverthrone Peak, is an eroded complex of lava domes that likely last erupted around 125,000 years ago. Remnants of other thick and steep eroded lava domes can be found around the complex, ranging in composition from andesite to rhyolite. However, the most visually interesting vents in this little-known volcanic complex are its subglacial vents, which originally formed underneath thick ice sheets during various Pleistocene glacial periods. One such cluster formed a series of flat-top vents termed toyas, including one which likely erupted at least twice to form a multi-layered flat-topped edifice. These various vents filled the bottom of the caldera over hundreds of thousands of years, although there clearly was a cluster of eruptions along the caldera ring faults. While it is difficult to be sure which vent produced the complex's youngest dated eruption, I am suggesting that the 8.5 kilometer or 5.3 mile long basaltic andesite lava flow originated from this highly eroded vent in the side of a local mountain. The eruption which produced this lava flow was likely a moderately explosive VEI-2 which formed a cinder cone, forming tall lava fountains, starting local wildfires, and creating a river of lava. More studies are needed on this picturesque volcanic complex. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.